Hello everyone. Today we're going to learn one of the most powerful and frequently used algorithms in computer science, which is binary search. Binary search is not just about finding a number in an array. Once you really understand it, you can use it to solve real-life problems. Before we start coding, there are three rules you must always remember. Rule number one, the data must be sorted. Binary search only works on sorted data. If the array is not sorted, the algorithm is invalid. Well, rule number two, we're gonna use a while loop. Well, of course, we can use the recursive function with the binary search as well, but in this video, we're gonna use while loop. And rule number three, the fail case exists. And so if the target does not exist, the start value over here will eventually become greater than the end value over here because of um, this formula over here, start equals median value plus 1. And that is how binary search ends. The fail case exists. So if you take a look at this picture over here, let's say median value is over here and the target we're going to find is over here. Then, median value is greater than the target value. So we have to shrink the range to left in this case. And so we can move the end value to medium minus 1. But on the other hand, let's say if target value is over here and median value is over here, then in this case, the target value is greater than median value. So we have to move the starting point over here. So that's why I make the formula over here, start equals median plus 1. And so on top of that, this is how we get the median value, and we don't care about the floating point. There we go. Well, this is our first example. So imagine we have a list of exams courses. We want to check whether a specific score exists. So if the score exists, we're going to print found. Otherwise, we're going to print not found. So let's move on to the coding part. I'm going to copy this test case first. I'm going to save it. We need a vector for the array. And we need the algorithm to sort out the courses. Well, first things first, I'm going to open the text file for the input. In the read mode. And then there should be a score. We need the vector, like I said. I'm going to name it courses. And then I'm going to sort out the score. Begin. And, well, you don't have to throw in anything for the last parameter over here because it is default for the ascending order. But I'm gonna write down the parameter for the ascending order. But if you want the descending order, you can throw in the code instead. This one, just so you know. And then I'm gonna check the monitor first. Well, it is sorted to the ascending order, as you probably can tell. And yeah, next up, we need the target. And then I'm gonna get the index from the binary search function. And if index is not -1, I'm gonna print out the score that we found from this function. Otherwise, I'm gonna print out not found. There we go. It should be an integer type, binary search. So first things first, we need the start point and ending point, which is courses size -1. And we're gonna skim through the while loop until this condition. We need the median value, which is start plus end divided by 2. And if courses median value is same with the target, then I'm gonna return the median value, which is our index, and I'm gonna check the values and shrinking the range of searching. If courses median value is greater than target, I'm gonna shrink the end, and otherwise I'm gonna move the starting point here. If we fail to find the target from this course's array, I'm gonna return -1. Yeah, I think this is all about the coding part. And so if I execute this file, 56 score is found. But if I throw in 12, not found. Yeah, this is how the binary search works. Well, let's move on to our last example for today. So imagine we are doing an interior renovation. There is one empty space left on the wall, and we know the area of that space, which is n, we're going to input in our code. And we have to fill it with square tiles only, since the manufacturer only makes square tiles whose side length is an integer only. That is our condition in our problem. Which square tile should we order to fill the wall as much as possible? That is our final question in our code. So I'm gonna print out that value. So let's move on to our Visual Studio. Well, first things first, I'm gonna write down this code first. And we need the wall area. And I'm gonna print out the value of the length of our tile from the binary search function. This must be an area. And we need the starting point, starting from 1. And this is our minimum length of the tile. And in this case, the maximum value of the length of the tile cannot exceed the value of area. So this will be the maximum. And this value, answer value, would be the best fit for the tile. And so let's just write down the basic code first for the medium value. If the area of the tile is perfectly matched with the empty area, which is very rare, you're gonna return the medium value right away, which means that this is perfectly matched with the empty space. Other than that, if the area is bigger than the tile that we choose over and over, then we have the opportunity to make the tile bigger and bigger. So we're gonna keep update the value of the best fit. So this tile is the best fit so far. And we're gonna shrink the range of our tile, try bigger tile. Otherwise, which means that we have to make the smaller tile. Tile is too large. And yeah, I think we just need to return the final value. So if I execute this file, and if the wall area is 8, then the maximum possible side length of the square tile is 2 in this case. What if 9? It will be 3. You can do whatever you want. What if 0? Yeah, 0 is very special exception in this case. 1 will be 1. I try it one more. 81. It will be 9. There we go. So this is all about today's video. I hope you find it very useful through this video. Thanks for watching, and see you on my next video. Bye guys.